13.6 Conditional probability formulas. For any two events A and B, the probability of B occurring given that event A has occurred is the probability of A and B over the probability of A, where the probability of A does not equal 0. This is the same thing we looked at in 13.5, except now they're going to provide us with just straight probability numbers like percents and decimals as opposed to whole units of people. If they provide us whole units of people or items, we can just go back to the probability condition or the conditional probability we saw yesterday. In a study designed to test the effectiveness of a new medication or new medicine, half of the volunteers received the medicine. The other half of the volunteers received a tablet containing no medicine. The probability of a volunteer receiving the drug and getting well was 45%. So they've given us a lot of information here. One of the things they told you is that half of the volunteers received the medicine and the other half did not. They also told you that the probability of someone receiving the medicine and getting well is 45%, or in terms of a decimal, 0.45. So in this problem, we're looking for the probability that someone got well given that they received the medication. So our probability of B given A is just the probability that someone got well given that they received the medicine. So that means that in order to do this probability, we're going to be looking at setting up the probability of someone getting well with the medication over the probability that they receive the medicine. So the probability of someone receiving the medication and getting well is 45%, or 0.45, and then the probability that someone received the medication is 50% because half the group received the medication, so 0.5. And so when we take 0.45 divided by 0.5, we get 0.9, or in this case, 90%. Example 2. The probability of a volunteer receiving the tablet with no medication and their health improving was 20%. So this is important. So in this case, it's 0.2 is our decimal version. What is the conditional probability of a volunteer's health improving given that they received no real medication? So once again, we're looking for the probability of B given A such that we're looking for the probability of their health improving given they received no real meds. So what this tells us is we're going to be taking the probability that someone improved with no meds over the probability that someone received no real meds. So in this case, improving with no real meds was 20%. So we're going to put 0.2 up top, and then the probability that someone did not receive the medication is just 50%, or 0.5, because half of the group did not receive real meds. So in this case, your probability of someone's health improving, given they didn't receive the real meds, is 0.4, or in this case, 40%. In this example, you have to understand that conditional probability isn't the same if you switch the order of the items. So the probability of B given A is not the same as the probability of A given B. So in example 1, in a survey of pet owners, 45% own a dog, 27% own a cat, and 12% own both a cat and a dog. So in the very first problem, or very first part of the problem, we are looking at the conditional probability that a dog owner also owns a cat. So we're looking for the probability that in this case you own a cat given that you already own a dog. So this means we're looking for the probability of owning a cat and a dog over the probability of owning just the dog. So that means we're going to have 0.12 or 12% over 0.45. Well, when you divide this, you get that the probability of someone owning a cat, given that they own a dog, is 0.267. The second part of this question, or part B, says, what is the conditional probability that a cat owner also owns a dog? So this time we're looking for the probability that someone owns a dog, given that they already own a cat. So we're looking for, once again, the probability of a cat and a dog over the probability of a cat in this case. Okay, so we have the probability of A and B over the probability of A. So in this case, we are looking for, or we're going to take 0.12, the probability of owning a cat and a dog, over the probability of owning a cat, which in this case is going to be 0.27. When you divide this, you're going to get that your probability is right around 0.444. The second problem states that in a survey of pet owners, 45% own a dog, 27% own a cat, and 12% own a dog and a cat. The same survey showed that 5% of pet owners own a dog, a cat, and at least one other type of pet. What is the conditional probability that a pet owner owns a cat and some other type of pet, given that they own a dog? So let's go ahead and try this one on our own, and I'll put the answer up in 5 seconds. So try pausing the video. So if you've done this one correctly, you're going to take the probability of owning other pets plus dogs and cats, so you own all the possible animals, so in this case you're 5%, over your probability of owning just the dog, which in this case would be 45%. When you divide those, you get right around 11.1%. Go ahead and try question 2B. This one states, what is the conditional probability that a pet owner owns a dog and some other pet, given that they own a cat? So for this one, you're taking the probability of owning a dog and other pets over the probability of owning a cat. So that's 0.05 or 5% over 0.27 or 27%. When you divide the two numbers, you get 0.185, which gives you 18.5%. So in the next section, we're going to get away from, I guess, traditional conditional probability where we're dividing by probability. In this case, we're going to be looking more at finding the probability of an overall event. So we're taking two events and multiplying them together to find our overall probability. And so I know that seems a little confusing, but just bear with me, because we're going to be using tree diagrams to find the probability of, let's say, graduating or winning games. And so once you get used to the tree diagram, it kind of works itself out. All right, so for the first one, we've got information here that's telling us that 70% of freshmen attended public schools, 60% of freshmen who attended public schools graduated within 5 years, and 80% of other freshmen graduated within 5 years. And so this tree diagram here was created to illustrate this information. It's showing if you went to public school, 70% of kids went to public school, 60% of them graduated in 5 years, 30% went to other schools, like private schools, and then 80% of them graduated in 5 years, and 20% of them did not. So we're going to use this tree diagram to find probability in the next slide. So, in example 1, what percentage of freshmen graduated within 5 years? So to determine our probability for this particular situation, we have to focus in on what they want us to find, and that is graduated. So we want to talk about what percentage graduated in 5 years. So what we're going to be looking at is just focusing in on the percentages that talk about graduation. So for the 70% that went to public school, 60% of them graduated. For the 30% that went to other, 80% of them graduated. So what we're looking at is we're going to find the probability of going to public school and graduating, and then the probability of going to other school and graduating, and then we're going to add those together. So let's set this up. So the probability of graduating from a public school, in order to find this, we're going to take the percentage of kids who went to a public school, in this case 0.7, times the percentage of kids who graduated from that public school, so 0.6. So this probability results in 0.42. Then to find the probability that they went to another school and graduated, we take the percentage of kids who went to the other school, which is 0.3, times the percentage that graduated from the other school, which is 0.8, and we multiply those together. All right, and notice that I've used the symbol for and here inside my parentheses, and that's why we're multiplying. All right, we've got the plus sign, just means and in this case. All right, and so when we multiply our 0.3 times our 0.8, we get 0.24. So right now we have the probability that they graduated from a public school and the probability that they graduated from other school. To find the overall probability that someone graduated, we just need to add these together. So in this case, you've got 0.42 plus 0.24, which gives us an overall probability of 0.66. So example 2. A soccer team wins 65% of its games on muddy fields and 30% of their games on dry fields. The probability of the field being muddy for their next game is 70%. What is the probability that the team will win their next game? So the focus of our probability is this win. We're looking for a win. So we're going to create a tree diagram to figure this out. So we're going to go ahead and create 2 branches, one leading to mud, one leading to dry. And then from each of these, we're going to create 2 more branches, one leading to wins, one leading to loss. Same here, wins and loss. There's a 70% chance of mud, so that means there's a 30% chance of dry for the next game. On muddy fields, they win 65% of the time, which means they lose 35% of the time. On dry fields, they win 30% of the time, which means they lose 70% of the time. So now if we're focusing in on when they win, we're going to focus in on just these values. So in this case, I don't like that. Let's go back. We're going to focus in on just those values. Let's see if we can highlight this. The 0.7 on the mud, and then the percentage for when they win it, so 0.65. And then the percentage for dry, and then when they win, of 0.3 when they win. So now what we can do is we can set up probability, where we're going to find the probability of winning with muddy field and the probability of winning with a dry field. And then we're going to add together those probabilities. So the probability of winning on a muddy field, we're just going to take the probability of the field being muddy, so 70%, times the probability of winning on that field, which would be 0.65. When you multiply these two together, you get 0.455. Then you're going to take the probability of winning on a dry field. Well, there's a chance of 30% they'll play on a dry field, and the probability of winning on that dry field is 30%. When you multiply these together, you get 0.09. So to determine the probability that they win regardless of weather, or regardless of field conditions, we're just going to add these two probabilities together. So in this case, we get a 0.45 plus 0.09 gives you 0.545. So there is about a 55% chance that the team wins their next game. Go ahead and try practice problem 3 on your own. Pause the video and then hit resume in a minute and check your answers. So we're going to calculate the probability that the star player plays and they win, which is 0.6 times 0.75, which gives you 0.45. Then you calculate the probability that he does not play and that they win, so you take 0.4 times 0.4, which gives you 0.16. So the probability that the team wins regardless of whether or not he plays or not is going to be 0.45 plus 0.16, which equals 0.61. So there's a 61% chance that the team will win even if the player does not play, or even if he plays or doesn't play in this case.